All right, let's talk about something we've all lived through. You've got a major incident on your hands, everyone's looking to you for answers, and all your dashboards are glowing a beautiful, serene, and completely useless green. We're going to talk about when your dashboards lie, and we'll unpack 3 real-world Azure war stories to figure out how to handle it.
So let's just put ourselves in that moment. Your app is failing, right? Users are screaming. The big question is, can you actually trust your telemetry? Because when the pressure is on, you need your data to tell you the unvarnished truth, not some comforting lie.
And that's exactly what we're going to do here. We're going to take 3 all-too-real Azure nightmares and turn them into a playbook. The goal? Proactive observability. By the time we're done, you'll have some real, concrete strategies to make sure your telemetry is working for you, not against you.
Okay, let's open our first case file. Case file number 1, I'm calling it Autoscale Chaos. You'll probably recognize this one. It's the classic, it works, but sometimes it's slow, and then it's fine kind of problem.
Yeah, the ticket comes in, and it sounds just like this. The site is fast, then it's slow, then it's fast again. What is happening? You know, it's that wild, unpredictable performance that just drives engineers absolutely nuts and completely tanks user confidence. Where do you even start looking?
Well, naturally, the team looks at the usual suspects. And on the left, you can see the noise they were hearing. CPU is fine, memory is fine, everything looks perfectly normal. So the conclusion is, hey, the infrastructure seems healthy, must be something else. It's a total dead end. But the real story, the signal on the right, was buried in a place they weren't looking, the Autoscale action logs. And the revelation was a shocker. The system was frantically scaling up and then immediately scaling back down, over and over, every few minutes. It's a pattern called flapping. And that was the source of the chaos, totally invisible on their main dashboard.
So how do we fix this so it never happens again? The symptom was that crazy oscillating performance. The missing signal? Well, it was the autoscale events themselves. They just weren't being watched. So the new standard, step 3, is to start treating autoscaling like the critical system component it is. You have to instrument and alert on autoscale actions right inside your deployment templates. The system that's supposed to be saving you can't be a black box.
All right, let's move on to our next case file. Case file number 2. The SQL ghost. This one's all about those bugs that just appear and disappear, almost like they're haunting you. And the bug report just captures that frustration perfectly, doesn't it? Everything is fine for hours, then suddenly the API times out. It feels like a ghost in the machine. I mean, these are the absolute worst kinds of problems, right? They're impossible to reproduce when you want to, and they honestly make you question your own sanity. And just like before, the initial telemetry sent the team down completely the wrong path. On the left, we've got the noise, just a bunch of generic server-side timeout exceptions in the logs. So naturally, everyone blames the app server. But that was a total red herring. The real signal, the concrete cause, was a metric they weren't even looking at, SQL DTU percentage. Now, DTU just stands for Database Transaction Unit. It's basically Azure's measurement of database horsepower. And what the team found was that the database was hitting 100% DTU during peak loads and then just started throttling requests. The timeouts weren't some weird application bug, it was the platform itself hitting its limit. And this leads us to a really powerful solution. The symptom was those ghost-like API timeouts. The missing signal was that specific database performance metric, the DTU percentage. So the new standard is super simple but so important. For every single managed service you use, SQL, Cosmos DB, you name it, you absolutely must monitor its specific resource and throttling limits. It has to be a non-negotiable part of your monitoring setup. Okay, on to our final case file. And this one, well, this one's going to hit close to home for anyone who's ever had to manage a deployment pipeline. Case file number 3, deployment downfall. You know that feeling, right? That frantic message that hits Slack just moments after a release? We just deployed the update, and now the checkout feature is completely broken. Roll it back, now! It's that heart-stopping moment where a supposedly successful deployment instantly becomes a full-blown, all-hands-on-deck incident.
Now, here's what's so fascinating and so tricky about this one. The primary health check was actively lying to the team. You see on the left, the app service health check endpoint is returning a perfect 200 OK. The service is technically up. So, of course, everyone assumes the problem has to be in the new application code they just pushed. But the real signal, the truth, came from a completely different tool, the Application Insights Dependency Map. This map, on the right, just visually laid out the whole system, and it immediately highlighted a big fat broken line to a third-party payment API. It turns out a tiny configuration change in the deployment had severed that connection, even though the web server itself was humming along just fine.
And this really shows the way to a permanent fix. The symptom? A specific feature breaks right after you deploy. The missing signal? That real-time end-to-end dependency tracking. So the new standard has to be about going beyond a simple health check. You have to integrate automated dependency health checks right into your CI/CD pipeline, and they have to run immediately after every deployment. Is the service up? That's great, but can it actually talk to the database? Can it reach the payment gateway? That is the real test of whether it's working. So after surviving these 3 war stories, we can finally step back and put together our proactive playbook. Let's call it the Never Again list.
Because look, the goal here isn't just to get better at fighting fires. It's not about diagnosing today's problem a little bit faster. It's about instrumenting our systems so well that the next diagnosis becomes trivial, almost boringly obvious. It's about building a system that tells you what's wrong long before your users ever have to. And here it is, 4 simple rules, all born from the fire of those incidents. First, log everything that acts, especially your automated systems like autoscaling. Second, track your limits. For every single PaaS service you use, know its limits and put a monitor on them. Third, map your dependencies. Remember, up is not the same as working. You have to validate those critical integrations. And finally, and this is probably the most important one, make it standard. Bake all of these checks into your default templates, into your pipelines, so nobody ever has to learn these painful lessons the hard way ever again.
So I'll leave you with this question to chew on for your own systems. When you look at your dashboards, at your alerts, what is that one missing signal you have right now? What's the one piece of information that, if you had it, would literally save you during your next outage?